This is the scenario acceleration due to gravity. So we're going to, first of all, put your name in. We are going to derive the formula for acceleration from data table. We're going to relate initial distance and acceleration formula and the speed in the falling body equation. After this scenario, you will be able to give the gravitational constant on Earth for USCS and SI units and relate how initial speed and distance affect a falling body. You can watch the video here. Galileo did experiments in falling bodies. He dropped and threw objects at various speeds and determined how those variables changed the falling rate and time. Newton used Galileo's experiments to discover the equation and we use to describe how objects' speed, distance, and acceleration and time are related. We now know that the acceleration due to gravity is a constant, and we also know how fast an object travels depends on the variables distance, acceleration, and time. So here we see a table that shows the time and the distance an object falls. It says select both the time and the distance columns at the left. Okay, we did that. Click Insert tab and the scatter plot and put it to the right. Click a dot on the graph, right-click a dot on the graph, and select Add Trend Line, and make it a polynomial of degree 2, and display the equation and the r-squared value on the chart. And when you do, you will see here is the equation. Y equals negative 4.9 x squared minus 2 times e to the negative 13 is essentially 0. It should be 0, but for some reason, it found 0.000, do that 13 times, and then a 2, and that's what it found is the of the value. Okay, the coefficient of x. So if you notice here, as the object falls, it goes faster and faster. So what happens to the distance as the time increases? The distance increases downward. What happens to the object when it reaches negative 122 meters? Well, if you notice, at 5 seconds it's negative 122, at 6 seconds it's negative 122, and 7 and 8, so it must have hit the bottom. And then, what is the trend line equation? The trend line equation is negative 4.9 x squared. Remember to ignore the other stuff. So that is finding the gravitational equation, negative 4.9 x squared. Let's graph the speed. Okay, speed is the slope of the graph. Slope is the change in y over the change in x. Well, if you notice, the time is a quarter second for each one of our distances. So the change in distance is the distance subtract the previous distance. And if you notice, when we pull that down, the distance increases, which is what we said before. The speed, it says, is the change in distance. So it's the change in distance divided by the change in time. And if you notice, the speed gets bigger as we go farther down. So it says select the time, distance, and speed graphs. I'm going to select them where they all three have values so that I can put them in. Insert another scatter plot. And we're going to have to change the names here a little bit so that they match what we've got. I'm going to click on the graph, right click, and then select data, and I'm going to change the name of the first one to distance, because that's the distance graph, and I'm going to change the name of the second one to the speed, because as I said before, that second equation is the speed graph. Now you can see the two together here. We already graphed the equation for these dots. Let's right click and add a trend line for that second one. If you notice, it's a line, so we can show that the equation for that line on our graph here. And if you notice, our equation comes up negative 9.8x plus 1.225. And the reason for that is that the initial speed is negative 1.225. All right, so what happens to the speed as the time increases? The speed increases downward. Why is the speed negative? Because the object is going down. What is the trend line equation? Negative 9.8 x squared plus 1.25 x. Let's see, data. I have to allow this data. Okay, W it's supposed to be, not X. There we go. Negative 9.8 x squared plus 1.25 x. All right, next. So as you can see, the speed, what is the trend line equation for speed? It's negative 9.8 times whatever the speed is at first, or whatever the time is, excuse me. Now we're looking for the change in speed. Well, the change in speed we can't do in the first spot. We actually have to do it in the second spot because you need to subtract. Change in speed is the speed subtracted from the first one. Acceleration is the change in speed divided by the change in time. And so we can highlight both of those cells and pull them down, and we get our graph. Now we're going to select the time, distance, speed, and acceleration and put all of those on a scatter plot. Let's put it right up here. And we have to change the names. This first one, select data. Change the first one to distance. Change the second one to speed. And change the third one to acceleration. Okay, so we have the first two equations. Let's get the equation for these dots here at a trend line. And when we do, you will see that there is essentially no x coefficient. It's just negative 9.8. So what happens to the acceleration? If you notice, the acceleration stays even. It stays constant. Why is it negative? Because the object is going down. What is the trend line for acceleration? Well, it's negative 9.8. What is the constant term? Negative 9.8. 9.8. And then multiply the coefficient in x in number one's graph. So coefficient of x is negative 4.9. So I'm going to type equals negative 4.9 times 2. And what do you notice about those two? They are the same. They are equal. So, as an object goes down, its speed increases downward, but its acceleration remains the same. This graph shows the equation as it is. 1/2 acceleration times the x squared plus the distance, or speed, times the x plus the distance. And x is always time. So the acceleration is, take 1/2, or multiply negative 4.9 by 2, you get negative 9.8. And that's what each of these accelerations is. The acceleration is always negative 9.8 if you're in the metric. If you're in the USCS system, it's 32 feet per second squared. Speed, in the first case, it's 100. In the second case, it's 100. And in the third case, it's 25. And that's just the coefficient of x. In the first case, it's upward because it's positive. In the second case, it's downward because it's negative. And in the third case, it's upward because it's positive. The initial distance is 150 in the first case, 200 in the second case, 100 in the third case. In the first case, it's above ground. In the second case, it's above ground. And in the third case, it's below ground. And we have all earned all 30 points, and that's how you do this assignment.